Okay, it's time to start. I'm going to start now. I am Armel Luce, and I'm working at Orange. I'm a database administrator at Orange. And now I'm also a Cassandra administrator at Orange. At Orange, we've been using Cassandra for a few months now, and I'm very happy to share our Cassandra experience with you today. Here is what I'm going to talk about. At first, I shall give you a short description of our application PNS, and I shall also explain why we chose Cassandra for this application. Then I shall explain also how we did the migration of our relational database to Cassandra without any interruption of service. I shall show you also the first results after the migration, how our application behaves now with Cassandra. I shall also explain what we are going to do during the next month. We would like to do some analytics with Hadoop, Pig, and Hive. And I shall also give you a few information about some open source modules which have been open sourced by the Orange teams and are available from GitHub. PNS means Profiles and Syndication. This is a highly available service for collecting and serving data about our customers. We store nearly 6 terabytes of data in our database. We have a few hundreds of properties for each customer. We store many kinds of data. For example, we have elementary items which are stored in single worker columns, for example, the first name or the last name of our customer. We store also some data in JSON or XML format. In this case, we store them also in large worker columns. In our relational database, we store also some data in a CSV format. Now we prefer to use the collection types with Cassandra. We have daily peaks at nearly 10,000 requests per second every day. And because our users are our customers and the sellers in our shops, we need very high availability and low latency for this application. Here is the big picture of our application. You can see here on the bottom, there are some data providers who send files to our application, and we inject those data in our database. There are also here some users who send also HTTP requests for querying or updating our database. So we receive them in a pool of web servers, and we send the database queries, and the web servers then send return the results to the users. Because we need very high availability, our architecture is based on 2 data centers. The first one is in Bagnolet, near Paris, and the second one is at the seaside in the south of France, in Sophia Antipolis. Before using Cassandra, we were using 2 database engines. The first one is a MySQL cluster for data which are very frequently updated. And the second one is a Postgres engine with a sharding and application for more static data. For example, data which are very frequently updated are the number of unread mails in the mailbox of our customer. And an example of more static data are the identity of our customer. We have 2 web services. At first, a web service written in C++, and the second one is written in PHP. And also, we use Python modules for injection of data that we receive from other data providers. Here are some key dates of our project PNS 3.0. PNS 3.0 is the name of a project for the migration of our data from the relational database to Cassandra. At first, from 2010 until 2012, I did a large study about a few NoSQL databases. And I did some bench, and I compared Cassandra, MongoDB, React, HBase, Hypertable. I didn't only read the documentation, but I install each time for each NoSQL I install a cluster in 2 data centers. And I did some tests of robustness, of performance. I voluntarily killed some nodes. I did some backup, restore of data, and so on. And at the end of this study, we chose Cassandra for our application PNS. In June 2012, we started really our project PNS 3.0. So we started by the design phase. A few months later, we did a proof of concept. So we started the first Cassandra cluster in production for a non-critical application. In April 2013, we started the migration of a first subset of data from our relational database to Cassandra. And since April, we are doing the migration of all of our data from our relational database to Cassandra. And also, we are going to add new nodes in our cluster. So currently, we have 8 nodes in each data center, and we are going to add 8 new nodes in each data center. And also, we are going to add a third data center in our cluster for analytics. And I shall explain how and why in the next slide. Why did we choose Cassandra? At first, if we look at our requirements, we need very high availability. And with our PNS2 platform, with a relational database, we were at 99.95% of availability. And we want to improve it. But we think that with relational database, it's difficult and probably expensive. About latency, with our old relational database, the response time of our web service was between 20 milliseconds and 150 milliseconds. And we want to improve it too. About scalability, we would like to open our service to new opportunities, to new businesses. And for that, we need to store more and more data in our cluster and to be able to execute more and more queries with the same quality of service, or if possible, with a better quality of service. That's the reason why we need also scalability. When I did my study about NoSQL, I realized that there are several kinds of clusters. The first kind of cluster are the clusters with a ring architecture where all the nodes play the same role. For example, Cassandra or React. There are also some clusters which have a master-slave architecture. For example, MongoDB, Redis. There are also some clusters which are based on a distributed file system. For example, HBase or Hypertable. And it looks obvious to me that the cluster which offers the best availability are the cluster with a ring architecture where all the nodes play the same role. Because if one or more nodes crash, the other nodes are able to replace them immediately. Cassandra has a ring architecture. React has also a ring architecture. However, React is just a key value store. So it's not very convenient to store a few hundred of properties per key. But the reason why, about availability, I think that Cassandra is the best choice for my application PNS. About latency, Cassandra has also a best latency than React. Cassandra has a very good latency for update queries. And maybe, according to my test, the bench I did during my study, he had the best score for update queries. For read queries, MongoDB, according to my test, MongoDB was better, has a lower latency. But the difference is light. And the latency of Cassandra was totally acceptable for my application. That's the reason why here also I think that Cassandra is a good choice for my application. About scalability, probably most of you have already read the blogs of the Netflix team. They did some bench and they published about scalability, and they published their results a few years ago. Yeah. And they did the demonstration that Cassandra has a linear scalability. And also here, Cassandra looks like the good solution for my application PNS. I want to say also that Cassandra is easy to use. When I did my test, it was very easy to install at first, to operate. It was very easy to backup data, to restore data, to add new nodes in the cluster, to remove nodes. You don't need to switch over master and slave because you don't have master, you don't have slave. Cassandra is easy to use. There are also some features of Cassandra that I like very much. For example, Cassandra is rack-aware. And I think it is safe that Cassandra avoids to store two replicas of the same data, of the same value in the same rack, for example. I like also to be able to choose the consistency level for each request. And also, I have to execute a lot of very simple queries for my application. And Cassandra is very efficient for very simple queries. All those reasons make me think that Cassandra is a good choice for my application. Now I have chosen my database, so go for Cassandra. And now I would like to do the migration of my data, which are in my relational database, to Cassandra. I would like to do it without any interruption of service. PNS is a critical application for our launch. We don't want to stop it. PNS is an application which works 20 hours every day without any interruption. And I want to do this migration with the same quality of service during all the migration. And also, I want to guarantee that there will be no functional regression. So I'm going to explain how we did this migration. At first, we have decided to divide all our data into subsets of data and to do the migration subset by subset. The reason for that is that it's easier to manage. It's easier to do the coordination with our users. It's easier to check that the migration is complete and successful after the migration of a subset is done. And in case of problem, it's also easier to roll back. And we have defined a generic process that we use for all our subsets of data. During the migration, we use a couple of tools and tips. At first, we use an Apache module named moddup. This is an Apache module which has been developed by the launch teams, and it is available as open source now from the GitHub. This module is able to duplicate web requests, to filter them on some criteria, and to send the duplicated request in a second pool of web servers. In our case, for example, we were able to send during the migration, we were able to send all the HTTP requests that we received to our platform in our old PNS2 platform with the relational database, and to send only the update queries of a subset of data to the PNS3 platform. This module helped us to keep up to date our two databases during all the migration. And also, probably all of you know that each value stored in Cassandra has a timestamp. And it is possible from the client application to set this timestamp when inserting, updating, or deleting the data in Cassandra. And we use this feature to set an old timestamp to the values when we did the copy from our relational database to Cassandra, in such a way that the requests which were updating the data that we received from our customers, from our users during the migration, were overwriting the value which were in our relational database. Now I'm going to describe in most detail this migration. At first, we are like this. We have still our data providers in the bottom left who send every day files to our PNS2 platform. So we receive them in a server which is named what we name a batch injector. And from this server, we update our query using Python modules. And also, we receive HTTP requests, either read and write requests, and we receive them in a pool of web servers. And from this web server, we send the queries to our PNS2 platform, and we execute queries in our relational database, and we send the result to our users. At first, when we start a migration, at first we create the new tables and new columns in our Cassandra cluster. Then we duplicate all the update streams. It means that here you can see we copy the files that we received from our data providers to a second batch injector, and we use this second batch injector to update our Cassandra cluster. And also, thanks to moddup, we are also able to send only the update queries of a subset of data to a second pool of web servers, and from this pool of web servers, we update the Cassandra cluster in our new platform. Then we copy all the data of the subset from our relational database to Cassandra, and we take care to set the timestamp to an old value. Once this copy is done, our two databases, the Cassandra cluster in the PNS3 platform and the relational database in the PNS2 platform, are up to date. And our users are still querying our old platform, our PNS2 platform. Now we can take time to check that the migration is correct and successful. For that, we just have to extract all our data from both sides to compare them. And if we find an error, it's very easy to roll back because our old relational database is still up to date and our users are still querying this database. So we don't have anything to do except that we just have to start to update the Cassandra cluster, to analyze the error, and to retry later this migration. We can say like this many days if you want, or a few days, a few weeks, if you want to check that all our update stream, all our new update stream works correctly. We can do this check, this control a few times, and when we are sure that everything is correct and successful, then we just have to switch the reads of our users to the new pool of web servers, and our queries now, the re-queries of our users are now executed in the Cassandra cluster. Then we stop to update our old relational database. And now all our queries are executed in the Cassandra cluster, and the migration is done. With this process, we are able to do the migration without any interruption of service. We are able to switch progressively to Cassandra. We can take our time to check that everything is successful, and we are also able to roll back very easily without losing any update in case of problem. We just have to make sure that that all our queries are idempotent. Otherwise, I'm not sure that this process will work. And I want also to say that now we have a new module, a new Apache module, moddup, which is available and that we could reuse for other purposes. For example, if we would like to do some benchmark, if you would like to do some bench of a new hardware, for example, or of a new version of Cassandra, we could reuse this module to duplicate the queries from a production platform to a new bench platform and to do some bench if you want. Now the migration is done, but what happened to our application? How our application behaves? At first, if we look at the latency, we can see here a real improvement about the response time of our web service. There are three reasons for this improvement. The first one is that we did some modification in the code of our web service, and those modifications improved the response time. The second reason is that Cassandra has a very low latency for update queries, and we have improved also our response time thanks to Cassandra. The third reason is that we have changed our hardware, and now we are using Fusion I/O cards. And with Fusion I/O cards, the response time, the I/O operation are executed very, 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 very fastly. Now you can see here that the execution of a read query in a data, what I call a data node, is the node where a replica is stored. The execution of a read query in a data node is executed in a few hundreds of microseconds. It's very fast. If I want to compare with my old platform, with my PNS2 platform, for example, with Postgres, such a query was executed in between 7 milliseconds and 10 milliseconds. Here we talk in microseconds. So we are very happy with this latency. I think it is wonderful. And when I did this measure, I have to say also that I was using the default compaction strategy, the size-tiered compaction strategy. I did new bench recently with a leveled compaction strategy. And I've seen that I was still able to improve this response time. So we are very happy with that because we have already improved our response time, and we are still able to improve our response time. About availability. Unfortunately, 2 weeks after the migration of the first subset of data, 2 nodes failed. This happened during the night. I don't know why, but when a node fails, it always happens during the night. So an alarm was sent to a system administrator who was awakened. He had a look at the status of the application, at the status of the cluster. And he saw that there was no error, no impact on the quality of service. No error returned by the application. In that case, I have to say that when Cassandra returned an error to the application tried to resend the same query to another node. That's the reason why there was no error, yeah? And not really an impact on latency also. So he returned to sleep. And the node stayed down during a few hours without any problem. And of course, we repaired them a few hours later. Cassandra is really robust. Of course, it depends on the replication factor you use and the consistency level also. But here we had the demonstration that Cassandra works well in case of problem. About scalability, our activity is always growing, so we have every year more and more data to store, more and more queries to execute. And because Cassandra has a linear scalability, we can say that the capacity of a Cassandra cluster equals the capacity of a node multiplied by the number of nodes. So there are 2 ways to deal with this growth of activity. The first one, you can scale up. The second one, you can scale out. Virtual nodes are now available since Cassandra 1.2, since the beginning of this year, since the beginning of 2013. And with the virtual nodes now, it's very easy to add new nodes in a cluster. You just have to install Cassandra in new node to configure it, to set the cluster name, the seed list, and so on. To start Cassandra, and it works. We just have to make sure, because we use a network topology strategy, that the nodes are evenly distributed in the racks, but it's as simple as this. Now we are very happy because we are using Cassandra. We have an application which works very well. We have improved our quality of service. But now we would like to do some analytics with Cassandra, it's not easy. It's quite impossible because the aggregate functions that we typically use, such as average, min, max, sum, doesn't exist with SQL3, and that's normal. We are going to use Hadoop, Pig, and Hive. Here is the cluster that we have currently, or that we shall have at the end of this year. We shall have 2 data centers, 16 nodes in each data center. We have a replication factor of 3 in each data center. And the requests that are sent from the web servers in the first data center are sent to the Cassandra nodes in the first data center, and the same for the second data center. We are going to add a third data center for analytics. And because we don't need a very high availability, we shall set a replication factor of 1 only. So we shall need less storage space for this data center. We don't need also a very low latency. So we shall not use Fusion IO cards or SSD. We shall use cheaper disks. And also, we have noticed during our test that Hadoop, Pig, and Hive work better when you set the HSHA thrift server in Cassandra. So now we are going to add to have this kind of cluster. So we shall have nothing changed in the first data center and the second data center. You see here, there is a third data center with only 4 nodes. And in those 4 nodes, we have installed Cassandra, of course, because Cassandra belongs to the Cassandra cluster in the same cluster than the nodes in the data center 1 and data center 2. We have also installed Hadoop, Pig, and Hive in these 4 nodes. And our MapReduce task will be executed only in these 4 nodes. So they will have no impact on the quality of service of the online queries. We were afraid that if MapReduce tasks were executed in the nodes of the data center 1 and data center 2, this could have an impact on the quality of service of our online queries, because these tasks scan the tables, merge the data, and that's the reason why we have decided to have a third data center. Just a few words now about the contribution and about the open source modules, open source by Orange. At first, there is a PHP driver for Cassandra. This is the PHP driver that we use in production. With this driver, you are able to work with SQL-free tables. So you can use all the features of Cassandra 1.2. For example, you can use the compound keys, the collection types, and so on. It is available from GitHub. So thanks to Sandro and Mathieu for this driver. Moddup is also available from GitHub as open source. And this is the module that we use for the migration of our data. Thanks to Jonas and Emmanuel for this module. We use also a C driver for our web service, for our C++ web service. And this module is also available from SourceForge, from the SourceForge repository. And thanks also to Emmanuel again for this driver. So if you need this kind of driver of Moddup, you can easily download it. Do not hesitate to try them, to use them, and to send some feedback to our team. They should be very happy to receive your feedback. For conclusion now, what I can say is that our migration is not yet finished. However, our project looks like a success now already, because we have seen that we are able to improve our quality of service. Our latency is very low now. Our availability is very high. Our system administrator sleeps very well. We are able also to, we have also a very flexible scalability. So now we are able to store more data if we want. We are able to execute more queries if we want. We just have to add new nodes in our cluster and it works, and with the same quality of service. I am also very interested by all the ecosystem around Cassandra. So I already talked about Hadoop, Pig, and Hive here. And I was at the Cassandra Summit in San Francisco a few months ago. And there were very interesting demonstrations about some tools such as Storm, Spark, Shark, and so on. And probably we shall use them soon. I hope that to come next year, maybe, to talk about this. Some of them are very easy to use. For example, Pig and Hadoop are well integrated with Cassandra, because there are some Java classes which are provided from the Cassandra package. We had to use, however, we were not yet able to use it in production, because in production we have Cassandra 1.2 and 1.2.2, and these classes work since Cassandra 1.6, I think, and work better now with Cassandra 1.2.10. Hive, however, there is no Java class for Hive, and it's more difficult to use. But we have found an open source class for that, and we are going to use it soon, I hope. So now, what I can say is that for us, PNS3 works better. Our new platform, PNS3, works better than PNS2. That's sure now. We hope also that it will be cheaper, because now we have replaced 2 databases by only 1. So we need less hardware. And also because Cassandra is easier to operate than a relational database. For example, we don't have to switch over master-slave and so on. The system administrator at Orange now say, yeah, it's very, very easy to operate. They are very, very happy with Cassandra now. For us, however, we come from the relational world. So it was at the beginning. I have to say that it was difficult to design the database. For example, we had some reflex of the relational world. For example, we were trying to use too much the secondary indexes. For example, we were hesitating to use collection types. And I encourage you to use now a collection type, because for us it works. It's really better, and it works well. Okay, now I have finished, and thank you for your attention. So if you have any question.
Yes, about the integration with Hadoop ecosystem. Do you write down the data, do you read and write the data into Cassandra directly, or do you still use HDFS for Hadoop?
We use HDFS, yeah.
So
and also we are going to integrate, to connect Hadoop to Cassandra directly also.
okay. So the idea is to bypass HDFS, or you still?
Yeah.
Right now, do we have all the tools? For example, for PIC, you say that it is integrated with Cassandra, but at which level? Driver or?
So there is a Java class, and that you can use. So it's difficult for me to answer because my engineer is not here. But I know that he has done this. And if you need more information about that, maybe come to see me, and I shall give you some information about that.
I've worked a lot with Hadoop with Cassandra, and yeah, there's a big storage handler, basically, a load func and a store func for both CQL and regular Cassandra's API, strict API, and then column family record reader and writer, and then there's a bulk record writer, so you can just shove a whole bunch of SS tables into Cassandra using Hadoop as well. The Hive stuff, there's an open source ticket on the Cassandra side, but also it's included in DataStax Enterprise if you're interested in that as well.
Yeah?
Was it necessary to have a completely separate third data center for Hadoop, or could you have had Hadoop nodes within each data center?
Now, could you repeat your question, please?
Was it necessary to have a different data center, the third data center for Hadoop, or could you have had Hadoop nodes within your cluster in each data center?
It is possible to have Hadoop in each data center, of course, but if our problem is that if we use Hadoop in the same nodes as our online queries, where our online queries are executed, we are afraid that this could have an impact in the quality of service of our online queries, because we don't want that, we are afraid that Hadoop will make scan of tables, sort, merge, and so on. We'll use a lot of resources in our nodes. And we are afraid that maybe we should not have a so good latency, and that's what we want to avoid.
do you link with the more traditional corporate data warehouse type structured analytics?
Not yet, no, we don't have.
You've shown you have made a large study about NoSQL databases.
Yeah.
Some of the stuff online, or
Sorry?
is some of the results from the study online or only at home?
It was, I did it, I don't understand your question. Okay. On the internet, yeah.
Another question, the PHP library, have you ever done benchmark against other PHP libraries like Apache Cassandra?
I'm sorry, I don't understand.
Have you ever made the benchmark of the PHP library against other Cassandra PHP libraries?
No, because for now it's not the same use case. We use PHP driver only for our online queries, while we use Hadoop and Pig and so on for analytics only.
Are you using some tools for monitoring, and then which one?
We have some internal tools at Orange that we use for all our platforms. PNS is only one application among a few other ones, and we have a tool for which is an internal tool for all these applications. Yeah.
Can you give us an idea of the overall size of the project? So how many customers, what your transaction volume was, what your data volume was, what your budget was for the project?
Okay. So we have daily peaks at 10,000 requests per second. We store nearly 6 terabytes of data. And we want to be able to store more and more data, but for now it's very difficult to, I cannot tell you how many data I shall have in 2 or 3 years. I don't know. But one of the reasons why we chose Cassandra, because we know that it's very, very scalable, and we are not afraid to store more and more data and to execute more and more queries in the future, thanks to Cassandra.
And the overall project cost?
This year it was expensive because we did the migration, we changed the hardware. We have to learn about Cassandra also. It was more expensive this year. I don't know exactly how, because I'm just a database administrator. But we hope that next year, as I said, it will be cheaper because the migration will be done. Our developers and our exploitation team will be more skilled with Cassandra. And maybe we shall have to add new hardware next year, because if we want to store more and more data to execute more queries, maybe we shall need more hardware. But we think that it will be cheaper now.
Okay, and so was the project justified in terms of its cost based on the service improvement, or actually in cost reduction as well?
My manager told me at the beginning of this project, Armel, I would like an application which works better and cheaper.
Okay.
And it's okay. Any question?
How long does your repairs take? I assume you do schedule repairs every now and again. How long does that take to do?
Yeah, we have scheduled our repairs. We have each node, there is a repair on each node every week. So we have scheduled our repairs during the night. It takes nearly, we don't have a lot of data now, so it takes nearly 2 hours per node. And it's during the night, so there is there is a lower activity during the night. So it's not a problem for us.
Are you reading and writing on both data centers?
Yeah.
What is your consistency level according to the multiple data centers?
we don't need a strong consistency. So quite 95% of our requests use a consistency level of 1. And we have some cases where we need strong consistency. In this case, we use local quorum, and we stick the reads and the writes of the users who need strong consistency in the same data center.
Are you planning your next Cassandra upgrade, version upgrade already, or are you
No. Currently, we have a Cassandra 1.2.2 with a few patches backported from 1.2.3. We plan to, we have scheduled an upgrade at the beginning of the next year. So at first, I think we shall upgrade to 1.2.10 maybe. For two reasons for that. At first, our version here is not compatible with Hadoop Pig and Hive. And the second reason is that we need to upgrade to 1.2.x greater than 9 if we want then to upgrade to 2.0.x.
Do you think your upgrade strategy will follow a similar migration approach, or do you?
No, I don't think so.
You plan to just upgrade binaries and?
I think that we are still thinking about the process of the upgrade, but I think that at first we shall try to upgrade at first one node, stay with one node upgrading during a few days, maybe 1 week. Then we shall upgrade all the other nodes in the same data center. We shall stay like this during, again, 1 week, and then we shall upgrade the second data center. That's what we are planning to do for now. Is there, okay, no, it's finished. Thank you very much for your attention.
Je travaille sur le projet Libon là, chez Orange Valley.
Ah, d'accord.
Et on utilise Cassandra aussi. En fait, on va déployer là. Et enfin, on est déjà en prod avec Cassandra sur du Street. On est en train de faire